Hi everyone, welcome to our Senior Design 1 poster. My name is Kayzaran Kabaj and I'm team lead. We are Team Biorobotic and our project is automating restroom help for arm amputees. I'll move it on to Eric to cover the objective.
The biorobotic prototype aims to bring independence and better quality of life to arm amputees by assisting them with pulling their pants up and down while using the public restroom. And now I will move this on to Kayla.
So I'll be covering some of the project summary, starting with our background and what inspired this project. Studies showed that a functional prosthetic arm costs around $10,000 to $100,000, which is well out of a lot of people's price range. Also, arm amputees they require other people's help to use the restroom, so it robs them of their independence. So some specifications for our project. We want it to be non-irritating, water and sweat resistant. It should operate between 20 to 120 degrees Fahrenheit, weigh less than 10 pounds, and cost $500 to $1,000. And I'll pass it back to Kazron to go the requirements.
So the requirements that we had to use to design our prototype included it being a wearable technology device that's worn around the midsection and will help with pulling the pants up and down by the push of a button. It will also be easy to put on at home with the assistance of a family member or a friend so that the disabled can go out and be more independent. And now in regards to our design overview, on the left-hand side, you can see a view of the device when it's deactivated, while on the right-hand side, you can see a view of it when it's activated. We have also labeled our button, our mechanical and electrical housings, as well as our clip. And now I'm going to move it on to Caitlin.
This is our overall mechanical subsystem. These are three up-close images of what's in our housing device. In figure 1 is our servo motor, which is in blue, connected to our drum, which is in orange. Our servo motor contains 2 gears with a gear ratio of 2 to 1. Our bigger gear is connected to our drum by 4 screws. In figure 2, this is our housing with our servo motor and drum all placed inside. Our housing is in gray. And in figure 3, this shows when the device is activated with the chain uncooled and the chain is in green. And now I'll pass this on to Tate.
Below is the electrical subsystem. It is displaying all the electrical components and how they will be wired together. The subsystem is composed of a power source, a microcontroller, 2 servo motors, a button circuit, and then a voltage step-down buck converter to provide the correct amount of voltage for each motor. Below you will see a flowchart of our Senior Design 2 plans. Improving our designs includes decreasing the overall size of the entire housing, and then printing the housing, and then implementing the code and running multiple tests to make sure that our prototype works. I'd also like to thank our supporters, Dr. Zhang and Hannah Stokes.